All right, guys, here we go. Back to more graphing. We're in, I'll add something here. This is b over theta. And this is b over theta. So we're going to extend our graphing today. We're in our red, white, and blue day. So we're going to do the tangent of theta, cotangent of theta. We're going to graph them. And then we're going to do the secant of theta and the secant of theta. So again, I'm going to pull everything off the unit circle. So if you want to get that out, the unit circle out, and if you want to pause the video, and I'll step out of the way here, pause the video, and then you can copy all this down, and then I'll talk about it. So, all right, here we go. So if we're working with the tangent of theta, this is actually y equals a tangent b of theta. We just got to remember on the unit circle that theta is sine of theta over cosine of theta, or it's the y value over the x value. So as we go around the unit circle, we're going to put the y value over the x value. So if we go to 0 radians, so we're starting, I'll draw it here. So if we draw the unit circle, if we go to 0 radians, my point is 1 and 0. So y over x gives me 0 over 1. 0 divided by 1 is 0. Well, if I move to the top at 90 degrees, or pi over 2, I get 0 and 1. Well, if I do y over x, I get 1 over 0. So as we move around the unit circle, as we move around the unit circle and we put y over x, we get 0, undefined, UND means undefined, 0, undefined, and 0. So it's a repeated pattern. And then once we get back to here, the pattern repeat is done. So what does undefined mean? Undefined is a spot in the graph where the line cannot touch. We call them asymptotes, and they're just a dotted line. That's why it's in red, at pi over 2. And so then we go here, 3 pi over 2, and we put our dotted line. Now, this graph here, if you plug in all the other numbers, it would have a pattern that looks like this. Because my x-intercept is at 0 and 0, or should say pi and 0, and then this would go up here. This one would repeat itself like that, and then it would just repeat itself like this with another dotted line right here, and then we'd work our way through. So the biggest points of tangent is, this is the undefined line, which we call an asymptote. Okay, so it's a dotted line that the graph cannot touch because it doesn't exist right there. And so tangent repeats this pattern like this. Now, the trick to tangent is it's got a different period. The period, it repeats itself between here. So if I take my x value, my x1, x2, so this is my second value. If I take, so x2 equals 3 pi over 2, and my x1 equals pi over 2. Sorry guys, I'm getting a little low here. My x1 equals pi over 2. If I subtract those two, I'll get the period. So the period can also be written as x2 minus x1, which is going to be 3 pi over 2 minus pi over 2, which is going to be 2 pi over 2, which, if we simplify it, the period on this one is equal to pi. So the period is equal to pi. So these are pi long. They're not as long as tangent, cosine and sine, so they're pi long. Now, if we take this concept here and we move it to cotangent, remember cotangent is just tangent flipped over. So if we take tangent and flip it over, it becomes 1 over 0. We have 1 over 0. If we take undefined, that is 1 over 0, and we flip it over, we get 0 over 1. So what happens is where tangent was 0, it becomes undefined, and where tangent was undefined, it becomes 0. So we go undefined 0, undefined 0, undefined as we move our way around each 90 degrees. Notice I wrote this in radians, and I labeled it radians, pi over 2, pi, 3 pi over 2, and 2 pi. This one I wrote in degrees, 90, 180, 270, 360. You need to be able to recognize that these are the same thing. All right, so let's tackle this one. Take my red lines. So for cotangent, we're here. We have another one here and another one here. All right, so now I'll take, let's just take blue right now. I have a 0 here and a 0 here. So if cotangent is tangent flipped over, let's look at the graph. If we flip this graph over, it's going to start from up here and curve this way. And then it repeats itself right here. So let's just look at this period here. When does one cycle repeat itself? Well, it repeats itself at x2 is equal to 180, x1 is equal to 0. So if I subtract those, the period is equal to x2, oops, not x squared, x2 minus x1. And so that's going to be 180 minus 0, which is 180 degrees. Or we could call that pi. So the period for this one is also 180 degrees, or pi. So that's how you graph tangent and cotangent. Now, when we're dealing with B and stuff like that, it does the same thing. B is going to shrink. You're going to divide the period. Now the period you're going to divide by 180. And we'll do an example right at the very end. I'm going to show you guys cosecant and secant here in a second. Okay? So that's your basic ones there. A is not going to affect these guys too much, just so you know. All right. So let's get rid of this. And I'm going to write my next one here. So y equals a cosecant b over theta, and we have y equals a cosecant b over theta. All right, so here we go. So we have to remember one thing, that this is really a times 1 over the sine of b of theta. So we're going to base this graph off the sine graph. So let's do our input-output table. So this is going to be, I'll do radians here, and I'll do cosecant of theta, which is really 1 over the sine of theta. So if you go back and look at your sine graph, and we write this out here, that's going to be too much. I'm not going to have room for my graph. Here we go, guys. Pi, 3 pi, oops, 3 pi over 2. And we have our 2 pi. All right, so go back to sine. We know that sine, and you know what I'm going to do for you guys? If I go back, I'm going to go back and put this here. So I'm going to do, right, don't forget this is 1 over the sine of theta. I'm going to write the sine of theta off to the side here. So what we're really saying is the sine of theta is 0, 1, 0, negative 1, and 0. That means the cosine of theta is, if we're flipping it over, is going to be 1 over 0, 1 over 1, 1 over 0, negative 1 over 1, and 1 over 0. So what does that get us? That gets us undefined. That gets us 1, undefined, negative 1, and undefined. All right. So remember, these came from the y value on the unit circle. And then all I did from there is I flipped them over to get my cosecant. So what does this do to the graph? Let's tackle this here real quick. All right. So we know we have my radians, so this axis is in radians. This axis is in cosecant of theta. And then I'll split them into pieces, pi over 2, 3 pi over 2. If you're noticing, those points never change unless there's a different b. And then I'll use my pink line. So I have an undefined right here. I have an undefined right here. And I have an undefined right here. So I'm going to draw the sine graph. So we'll call this 1 and call this negative 1. I'm going to do the sine graph in a dotted line right here. That's what the sine graph looks like. So the cosecant, since we're flipping it over and we've got a asymptote here and an asymptote here, all we do is we take the sine graph, we put our minimum right there, our dot right there, and we draw it up like this. And then we put our dot right here and we draw that, and we take those away, and I've just drawn my cosecant graph. Okay? So my cosecant graph is literally the sine graph chopped and flipped over, just like it's flipped over here. So let's go to my cosecant, which is really y equals a times 1 over cosine of theta. Oops, cosine b of theta. All right, so let's tackle this here. So if we do, I'll do degrees on this one again. So we'll do degrees. 0, 90, 180, 270, 360, which is the same as 0, pi, pi over 2, 3 pi over 2, and 360. I said them a little bit out of order. Excuse me. All right, so I'm going to do it a little differently. I'm going to put 1 over the cosine of theta here, which is the same as, this should be secant, guys, sorry. Secant. Change that in your notes if you wrote it down. This should be, and this is this is secant. All right. So let's look at this. So cosine here is at 1, so it'll become 1 over 1. Cosine here is 0, so this will become 1 over 0. Cosine at 180 is negative 1, so this becomes negative 1 over 1. Cosine at 270 is 0, so this becomes 1 over 0. And we're back here, which is the same point as that, and we're at 1 and 1. So we get 1, undefined, negative 1, undefined, and 1. So that's my secant. Now let's work with what we got here. So we have let me draw this down here a little bit lower. We have this. We have 360, 180, 270, 90. We have my 0, and this is secant of theta. So let's try draw my dotted lines at 90. So I have an asymptote here. I have an asymptote here. And then let's draw in my cosine graph. So my cosine graph, this is 1. This is -1. My cosine graph looks like this. But we want to graph 1 over cosine with cuts right here at the asymptotes. So this is going to get cut, and I'm going to go from here to here. So that one's gone. This one here, we cut it there, and it gets flipped over because it's reciprocal. And then the same thing here, we put our dot here, this gets cut and goes in a different direction. So that is what my secant graph looks like. It repeats its pattern every 360. Same thing here. It repeats its pattern every 2 pi. So the domains or the periods don't change on these between sine and cosine. They're still going to be 2 pi long. All right, so this is my last part, guys. Let me check my time here. 16 minutes. Let's see if we can do it in under 20 again. Lots of information for you guys. So, I'm going to tackle 2 of them here. So let's just say we have y equals 2 secant 4 theta. So let's just say my amplitude is 2. My period is now going to be 360 degrees divided by 4, which is going to be 90. So at 90 degrees, so now this is 90 degrees long. I now have a height of 2. And I know from my previous ones, if we cut that in half and we cut that in half, and this is going to be 67.5. So basically this is 1/4, 1/4 times 90, 1/2 times 90. And then if you look back at secant, we draw our basic cosine graph. Oops. And we cut it wherever it touches 0. And we flip it. That one's gone. That one's gone. That one's gone. All right, guys, so here's where we're looking at. This is my graph. The new amplitude or the starting point is at 2 and -2. And then we work from there. We cut our period down by B, which is now 90 degrees long. So my period is 90 degrees long, and those are my points right there. That's how you graph these guys. And so good luck with that. And if you need some help, we'll be in our office hours. We'll talk to you guys later. Let's see if I made it in under 20. Woo! Made it.